the top node is the root node. So it will going to specify a testing conditions of which the outcome corresponds to a branch which is leading up to an internal node. C4.5 and CART and CHAID. So these are the popularly used algorithm in order to make a decision tree. So if I am making assignment decision, at that time the node which comes from that particular class will be termed as a terminal node or a last leaf node. Hello everybody, a warm welcome to one and all. I am Rohini TS from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we are dealing with a BCA's final year, that is semester 5 of a subject called Cloud Computing and Big Data Analytics, and we are in the unit 4 of a last session, that is session 3 of a unit called Data Pre-Processing and Analytics. So let me get into the today's session. So now we'll see what is this linear regression is all about. So it is a baseline modeling technique to model a continuous target variable, that is used to model a continuous target variable. So in order to represent the continuous target variable, we are going to have this linear regression model. So here let me take one example. In a CLV modeling context, a linear regression model can be defined to model CLV in the terms of RFM. So this R represent recency and frequency and monetary value. So these will be the continuous target variables. So and we can get the predictors, that means we can get the targeted prediction with the help of CLV, that is using is equal to beta 0 plus beta 1 or R is nothing but this recency plus and B2F plus B3M, that is related to monetary. What is the main advantage of having this linear regression? That is, it is very simple to use and usually works very well. So here you can see that line, that is here we have a 2 dimension, one is X, another one is Y. So here mainly we are going to have a modeling that is mainly based to have a continuous target variable. So if you see the variables, it will be continuous in nature. So we are going to use this in order to get to know the prediction of the target variable. For that purpose, we will be using this linear regression model. And also you can consider that here beta, so that represents the parameters are then typically estimated using the ordinary least squares. So that indicates OLS to minimize the sum of squared errors. So here you can see that. So we are going to use this beta as a parameter. The main intention is to what? It has to reduce the sum of this squared variables or a squared errors. So as a part of the estimation, one then also obtains the standard errors. Though we are going to get the standard errors, here P values indicates that variable importance. So it indicates how the variable is important in order to minimize that standard errors, and also confidence intervals that represent, that P represents the indication of the importance of a variable along with the confidence intervals, and that B represents the parameter which is based on the OLS, that is ordinary least squares. So this is regarding linear regression. We'll see about the logistic regression. So when the modeling the response using the linear regression, one will going to get like by making use of a linear regression for that model, we are going to get equation like y is equal to b0 plus b1 age plus b2 income plus b3 gender. So they are taking 3 categories and they are giving the parameters as b, and we are finding the target variables. And when estimating this using OLS, that is this ordinary least square. So when we are using this regression model or a linear regression model, we are going to get 2 problems. What is the first one? The errors or targets are not normally distributed but follow a Bernoulli distribution. So this errors or any of the target which is not going distributed normally, though it will going to have or it will going to follow Bernoulli distribution. So it can be distributed in a descriptive manner. So that means no evidence or no things will going to be takes place. It will be distributed normally. So it will be based on the type of error that we are going to get when we are squaring this error. And also we have to consider another problem. There is no guarantee that target is between 0 and 1. So I can't predict that the value will going to be only between 0 and 1. So it can be either lesser than 0, even greater than 0. So which would be handy because it can be then interpreted as a probability. So here we are thinking about the probability. It can be either between 0 and 1 or even greater than 1 or even lesser than 0. So you can see here. So here values are distributed not only between 0 and 1. In another way also the values has been distributed. So here you can see that it is a bounding function for logistic distribution. Mainly we have two problems. Errors or targets is not normally distributed. That will be based on the Bernoulli distribution. Along with that, the variables or values which will not going to be guaranteed to be lies between 0 and 1. So it can be even greater than 1, even lesser than 0. The general formulation of the logistic regression model. How we are going to find the logistic regression model? By making use of this formula. So with the help of this formula, we are going to find the logistic regression. So this model will going to help in order to get the linear regression. So by making use of this logistic regression, we will get the linear regression that will be mainly used in order to get to know the target variable which is continuous in nature. So by making use of this formula, it can be further modified by taking an example of some of the parameters. So based on that parameter, this logistic regression will going to takes place. So you can see the distribution here. Here decision boundary of the logistic regression. So here we are taking a parameter of age and income. So here we can't predict that the values will going to be only between 0 and 1. So it can be even greater than 1 or even lesser than 0. So these are the problems we are supposed to face when it comes to the logistic regression. And we are going to group all the values which is of a similar variable and which is of a continuous target variables. So now we'll see about the decision tree. Next topic is decision tree. So here decision trees are the recursive partitioning algorithms that come up with a tree-like structure which representing a pattern in an underlying data set. So in a decision tree, how we are going to do the variables or how the variables will going to be distributed, it is like a tree structure. So it is a upwarded tree, or I can say this as a recursive partitioning algorithm. In short, it will be termed as RPA. So why we are going to use this decision tree? In order to make a decision, it is a binary decision. Whether if the condition is true, then it will take this part. If the condition is false, then it will take this part. Even though it is false, I will have to check the condition which is in the false part. So even if it is true, I have to check with the condition which is in the right side. So here if it is a tree-like structure, there we have a node, there we have a links or edges. So you can see that the top node is the root node. So it will going to specify a testing conditions of which the outcome corresponds to a branch which is leading up to an internal node. So if you see the example here income is the root node. So this root node has two branches, like it will going to be either no or yes. Okay, you can see that when it is greater than $50,000, if it is true. So if it is true, then it will be yes. Then I will check if his age is lesser than 40. If it is true or false, that is, if it is yes, then we have to respond. If the age is not lesser than 40, then not respond. Okay, so we are going to call this node as a terminal node. First node or a top node will be termed as root node and a last node will be termed as leaf node or a terminal node. So that you can see here, the terminal nodes of the tree assign the classification and are also called the leaf of a tree or a leaf node. After assignment or after the calculations or decision making, the tree assign the classification. So here I am assigning the classification for this one. So if does not have any further classification, then that will be termed as leaf node or a terminal node. The top node will be termed as root node. And many algorithms have been suggested to construct a decision tree. With the help of some of the algorithms, we can construct this decision tree. Mainly, we are going to have popular, that is C4.5 and CART and CHAID. So these are the popularly used algorithm in order to make a decision tree. So these algorithms differs in their way of answering. So like whether I can take C4.5 and CART or CHAID, at the time these algorithm will going to take different form in the way of answering. So it will going to build a key decisions in order to build a tree. So what are the questions it consists of, or what are the different way of answering? First is what? Splitting decisions. So I have to think about which variable have to be split. For example, if I am taking a gender, so at that time if I wanted to split this or not, so if yes, whether it is female or male, so then further splitting is not required here. So if it is required, then I can think about the age. Okay, so if you are taking any of the variables, or if you are considering any of the value which can be split, what value? So that represents the splitting decision. So next question is what? Stopping decision. At what point I have to stop the splitting? That is when to stop the growing of a tree. So if I got this age, then whether I wanted to make some of the grouping or segregations. So if not, at what point should I stop the questioning or stop growing of a tree? And we have a assignment decision. So in this, what class it is to assign to the leaf node. For example, if I consider this as a leaf node, this belongs to which class? Okay, if I am taking a gender, this will be the root node. If I consider this example, age will be the precedence of this terminal node. So at that time, this class will going to be the class of this particular terminal node or a leaf node. So these are the things we have to consider when we are answering or when we are building a decision tree with the help of this called C4.5 and then CART and then CHAID algorithms in order to develop a decision tree. So the assignment decision is the most straightforward to make since one typically looks at the majority class within the leaf node to make a decision. So with the help of this assignment decision, so if I am making assignment decision, at that time the node which comes from that particular class will be termed as a terminal node or a last leaf node. So that will going to help in order to make the decision. So at last what we are going to get as a leaf node, those are the answer for my questions. Then the other two decisions to be made are less straightforward and elaborated in what follows. For example, here we have a 3 questions, right? So within this, assignment decisions will going to be very straightforward, but these two is not so straightforward. That is what we are discussing here. And also this decision trees can be used for various purpose. So for what purpose we are using this decision tree? What is the first advantage? Can be used for input selection. So we can use this decision tree for the input selections, and also can be used in order to simplification of a calculate the gain of a characteristic to gauge its predictive power. And also decision tree will be used in order to build a 2 or 3 levels of decision making. So if I wanted to go further or deep, then we have to go with a regression models. So next, decision tree can also be used as the final analytical model, so that can be used directly into productions. And the main key advantage of this decision tree is that the decision trees gives a white box model with a clear explanation behind how it reaches its classification. It is transparent in nature. If I am arriving to some of the solutions or a decision, with the help of this decision tree, I can get to know what was the thing happened previously in order to make this decision. That is the main advantage of having this decision tree. And also many software tools will also allow you to grow the trees interactively by providing a splitting option at each level of a tree. So if you have more splitting option in a tree, then that gives the more opportunity or more specification in order to build a decision tree. We'll see the next topic, that is related to neural network. As the name indicates, when I'm saying neural network, it is related to brain. How it will be related to brain? We'll see now. The first perspective on the origin of neural network states that they are the mathematical representation which is inspired by the functioning of a human brain. We are going to use this neural network in order to represent the activities or a functioning of a human brain in the terms of mathematical terms. For example, how the neurons is working, how the dendrites are working, how the signals are passing from one node to another node. If you are keeping all these records mathematically, then that will be termed as what? Neural network. Mainly it is a technique that will going to be used, or that states that the mathematical representation which is inspired by the function of a human brain. And also another more realistic perspective sees that neural networks are generalized of existing statistics models. Already we have some of the statistical model, so this neural network will be termed as realistic perspective model of this existing statistical model. So here we have the formula in order to get the neural network. So here you can see that it is just a mathematical representation of activities or functioning of the human brain. And also this model you can be seen here, so it will going to have some of the mathematical terminology, and it will check for the functionality of a human brain that will be converted into some mathematical functioning activities or some mathematical calculation part. So this will going to be helpful in order to get to know, or in order to find the signals of a human brain. And also the processing element or neuron in the middle basically performs the two operations. So here you can see that these are the neurons. So this will going to perform some of the operations. So it takes the input and multiplies them with the weights. So what is the first option it will going to do? It will take the inputs. You can see that it will going to take the input and multiplies that with the variables. That will going to be multiplied with the weights. So you can see that it will going to be multiply. All these are the input that will going to be multiplied. Then it will going to put this into the non-linear transformation function that you can see here. This is non-linear transformation function. It will take the input, this middle neuron will going to multiply, then at last it will put that as a non-linear formula or non-linear transformation function. So in this neural network, we have some of the popular transformation function that includes, or that will be called as quasi activation functions. So that includes, or that will going to be depicted with this formula, and all the variables which will going to be range between 0 and 1. If it is related to z, then it will be range between -infinity and +infinity. And also we are considering that these neural network models are very complex pattern and decision boundaries in the data, and such they are very powerful. We are going to use this neural network for decision making, but it will be considered as a complex pattern and decision boundaries, but it is powerful. Though it is difficult or a complex, but it will going to yield a powerful decision. So in fact, they are so powerful that they can even model the noise in the training data, which is something that definitely should be avoided. So though it has a useless data, though it has a noise in the input or a training data, this neural network will going to take the inputs and it will multiply, then it put that as a linear equation. That means it has a capability or ability to deal with the data which is of noise. That noise data can be anything. So, but this neural network has the ability to deal with that noise data even in the training data, and also which will needs to be avoided. That means noise needs to be avoided in the training data, but this neural network has the ability to deal with that noise data. This is regarding neural network. We'll see the next topic, that is descriptive analytics. So, as the name indicates, descriptive analytics, they summarize or describes the raw data and make it something that is interpretable by humans. That means what? It is giving opportunity to describe it more. So, I have a raw data or I have a raw information, raw elements, then this descriptive analytics allowing the user, that is making it something that interpretable by human, which can be understandable by human, which can be analyzed by human. So that kind of methodology or that kind of analysis will be termed as descriptive analytics. It will just going to give one sentence, but with a human interventions or with a interpretation of the human, it will going to allow in order to make it something which is in the descriptive manner, though it is a raw fact. That will be termed as what? Descriptive analytics. and there is no real target variable available for this descriptive analytics. Whatever the decision we are going to make, or however our thinking capability, instead of that there is no target variable which is available in the descriptive analysis. And also descriptive analytics is often referred as a unsupervised learning, because it is not going to specify, or it is not going to be based on specific rules and regulations. So it is what another kind of unsupervised learning, because there is no target variable to steer the learning process. So we are not going to set any target variable. It will be based on the perspective or interpretation of a human based on their capability. So it will be considered as what? Unsupervised, because we don't have any target variables. So the three most common types of descriptive analytics are, it will going to include associations rules, and it has a sequence rules, and one more is clustering. We'll see about the association rules. So here it will going to detect the frequently occurring pattern between the items. Why we are going to use this association rule? Mainly it will going to occurs, or it will going to think, or it will going to detect the frequently occurring pattern between the item. For example, if a person is buying a milk, then there will be a chances of buying a bread or bun too. So that means what? We can analyze, or we can detect the frequently occurring pattern which is between the items. And also we have a sequence rule. Mainly it will going to detect the sequences of a events. So that is related to sequence rules, or a checking or detecting of a sequences of the event. So you can detecting the sequence of purchase behavior in a supermarket context. So as I told, detecting sequences of a web page visits in a web mining context. So like for example, if you are scrolling a YouTube, at that time we will scroll on the shorts. Also we can go with some entertainment videos. That means we are going to do something in a sequential manner. That kind of associations will be termed as what? Sequence rules. And we have a clustering. So this will going to detect homogeneous segments of observation. That means it will going to collect the data and informations, or it will going to collect the variables which is of a similar type. That indicates the homogeneous segments of observation, and it differentiate between the brands in the marketing portfolio. You can take the example of vegetables corner, you can take the example of grains, or any of the household things. So it will just going to group, or it will going to have a collection of the homogeneous segments of the observation. So that will be termed as clustering. And you can take another example for association rule, detecting what products are frequently purchased together in a supermarket. As it told, a milk and a bun or a bread will be the example for this association rules. So these are the three types that we have in the descriptive analytics. Next we'll see about the social network analytics. Social network. What is this social network is all about? Like we are communicating, or we are building a network which is over the online, it is taking place. So here many types of social network exist in our day-to-day life. The most popular are undoubtedly, we can say, if I am asking you what are the examples of social media, so probably it will going to include Facebook, Twitter, LinkedIn, even Google Plus, Instagram. These are all the social medias. So however, social networks are more than that. So this social network will going to be more than the social media. So why I am using that word? It could be any set of nodes that will going to be referred as the vertices which is connected by edges in a particular business setting. So if I consider a business setting, that may be connection of several numbers of operators, several number of users, several numbers of application software. It will be a collection of, or it will be a combination or integration of set of nodes, or any set of nodes. Then that will be termed as what? Social network. Then what are the examples we have in a social network? It will going to include web pages which is connected by hyperlink. I know that most of you have observed that when you are searching something, you are going to get some words which is in blue color with underline. So if I click on that hyperlink, that will help me to take to another web page. So that is also what it is, building a network. It is creating a connection from one node to another node. That is also considered as one of the example. And we have a email traffic between the people, and research papers connected by the citations, more number of people will going to visit that locations. So that will going to be help in order to have more citations, and also telephone calls between the customer of a telco provider, and also banks connected by a liquidity dependencies. And one more example is spread of illness between the patients. It is also like you can take the best example of COVID. That means what it is spreading diseases. So it will going to build a network from one people to another people. Here also we are sharing our information. We are building a network of a social technology with the help of this social network analytics. So by looking into all these things, we can get to know that this social media or a social network analytics can be applied in a wide variety of different settings. There is no restriction of having this social network or a social network analytics. It has been spread or it has been distributed over the different areas or a different settings. This social network learning is the goal is that within the network classification to compute the marginal class membership probability of a particular node given the other nodes in the network. So if you see this image, at the time you can understand this, what is the probability. For example, if this person or a social media network connecting to how many other node of a single membership class. So here also we are thinking about what is its boundary. That will be going to be learned with the social network learning. That you can see here, the main goal is what is within network classification to compute the marginal class. I have to compute the marginal class membership probability of a particular node given the other nodes in the network. If I take an example of Instagram account, so there will be a possibility of having number of followers and a followings. So by having this social network or a social network learning, this will allows me in order to get to know how long it can be grown. That means what will be the limitations of that. That means it will compute the marginal class membership of a probability of particular node which is given the other nodes in the network. So this node will going to create how long, or this node will going to have how many connections. So this indicates that what is the marginal of this particular collection of nodes. So that is we are checking or we are computing its marginal class membership probability. So the various important challenges arise when we learning in the social network. So what are those challenges are we supposed to face when we are learning with this social network? We'll see that first key challenge is that data are not independent. As I told, if I have any of the social media account, then there will be a followers and following, right? So one node is depending on another node. So and identically distributed, an assumption often made in the classical statistical models that includes linear and logistic regressions. The main challenge is data is not independent. The data depends on one another node, and also the correlation behavior between the node implies that the class membership of one node might will going to be influence the class membership of related node. That means that one node will going to influence the another node in the related node. And also it is not easy to compute with a separation. So into a training set for model development and a test set for model validation. So just imagine if you have a 10,000 social media account, then there will be a difficulty of separation of having the test data as well as the training data. So how many social media account I can consider that as a test data, and remaining will be considered as a training set. So there will be a confusions or there will be a difficulty in order to make up or in order to have a separation between the training set as well as the testing set. What is the next challenge? There is a strong need for collective inferencing procedure because this inference is about the nodes can mutually influence one another. Anyway, it is not independent, so that we have to have a strong inference or a collective inference module. Then there will be a chances of having independency, because this inference is about how one node is influencing the another node. So that this collective inferencing is also going to place a very important role in facing the challenges of this social networking learning. And also many networks are huge in scale. If you considering number of nodes will going to be grows, then number of connections is also going to be very large. If it is huge, then it will must have the efficient computation procedure need to be developed to do the learning. So if the computation is not so efficient, then there will be a chances of misusing of this learning process of the social network. So by having this social networking learning process, one should not forget the traditional way of doing the analytics using only node specific information, because this can still prove to be very valuable information for the prediction as well. So this social network learning has not been proved as a powerful tool, though we have to take care about the traditional way of doing the analytics of a social network. So these are the challenges we have to face when we are having this learning social network. And also this social network learners will be usually consist of the following three components, that includes a local model, network model, and collective inferencing procedures. So these three are the models, or these three are the elements which comes under the social network learnings. I hope you all understood. Here I have listed out some of the important questions that you can expect in your examination. So you have to concentrate on all the 2 marks as well as the 10 marks, 8 marks. So that depends on the question how we are going to get. But for 2 marks also you have to concentrate some of the important topics which I have listed out here. So you can see the important question from this unit 4. It's all about cloud computing and big data analytics. Let me meet you in the new session with a new content. Until that, keep learning, keep on growing. Thank you so much.